For number one, a sample of pure gaseous hydrocarbon is introduced to pre. So you have the volume right here, the pressure right here, temperature to Kelvin. So 273, so that's 400 K. So PV is equal to nRT. We want to find the mole. So mole is equal to PV over RT. And pressure is 0.2 ATM. Volume, it's 1 liter. R is 0.0821. And temperature is 400. So 0.2 divided by 0.0821. And then divided by 400. So that means the mole is 6.09 times 10 to the negative 3 moles. O2 is introduced into the same vessel containing the hydrocarbon. After the addition of O2 gas, the total pressure goes up to 1.4 and calculate the partial pressure of O2 in the vessel. So we're talking about the same container, and the pressure was 0.2 for just the hydrocarbon. So PO2 is equal to 1.4 ATM minus 0.2 ATM, which is 1.2 ATM. And then the mixture of the hydrocarbon and oxygen is sparked so that the complete combustion reaction occurs, producing CO2 and H2O. The partial pressure of these gases at 127 are these. There is O2 remaining. So that means the hydrocarbon is the limiting reactant. Use the partial pressure of CO2 and H2O to calculate the partial pressure of O2. They told you at the beginning, yeah. So use the partial pressure of CO2 and H2O to calculate the partial pressure of O2. Okay, wait, hold on. Use the partial pressure of CO2 and H2O. So no, this is something new I found online. Oh, okay. So you have the hydrocarbon plus O2, giving you CO2 and H2O. Now, one thing that we know for sure is that the hydrocarbon is the limiting reactant. It's completely gone. So the mole ratio, well, if you say it is 1 hydrocarbon for the coefficient, then, I mean, you can use 2, doesn't matter. But that should be the case. Yes, that should be the case. So you could actually figure out the actual hydrocarbon because you've got 3 carbons on the right and 8 hydrogen atoms. So that means the hydrocarbon of interest is C3H8. Or at least C3H8. How do you find what? So that's why you need to use stoichiometry. Okay. So basically, how many O2s are right here? You have a total of, on the right-hand side, you have 6 oxygen atoms. 10 oxygen atoms. That means the coefficient over on the left, 5. So if the ratio is 1 to 5, so to consume 0.2 ATM, that would mean you would consume 1 ATM of O2 consumed. And how much? That's given to us from the very beginning. Okay. And we had how much to begin with? We had 1.2 ATM to begin with. So that means our remaining partial pressure of O2 is 2 atmosphere. So this one is particularly challenging because this requires you to know the Avogadro's principle. That you can use the pressure or partial pressure is directly related to the quantities. So if the temperature and volume remain constant, you can use pressure to judge the molecules. Yes, and based on the information, we can now go ahead and write down our balance equation. And then you can calculate the mass of hydrocarbon that was combusted. So that's basically changing this moles into mass using the molar mass of propane. And then the hydrocarbon is readily soluble in water. Its solution was prepared by mixing 5 grams of hydrocarbon and 100 grams of water. Calculate the freezing point. Now you can skip F because there's no freezing point depression right here. So I think the hardest part is the one with the balance equation.